Hello everyone, let's continue the series Roadmap to Become Competitive Programmer 5 Star. So in this video I'll be explaining you the problem Primality Test. Basically we are checking the prime number. So let's figure out the problem. Alice and Bob are meeting after a long time. As usual they love to play some math games. This time Alice takes the call and decides the game. So the game is very simple. Alice says out an integer and Bob has to say whether the number is prime or not. Bob as usual knows the logic, but since Alice doesn't give Bob much time to think, so Bob decides to write a computer program. So help Bob accomplish this task by writing a computer program which will calculate whether the number is prime or not. And they have given note that 1 is not a prime number. So okay, we'll be dealing with this, but before that let's type the input. We have test cases, multiple test cases we have, so let's deal with the test case. So for every test case we are going to call a function solve. And for every test case we have one integer n, which will denote the number given by Alice to the Bob. So there have been 5 test cases. Let's try to understand. In the first test case we have 23. So in the first example n is 23. So Alice has given to Bob the number n, and Bob has to decide whether it is a prime number or not. So by definition of the prime number, as we know, prime number is basically a number which is divisible by itself and 1. Divisible by itself and 1. Itself meaning it should be divisible by same number here. It means, let's say you have taken 2, and if you try to take any number which divides 2, and also one of the definition is that the prime numbers are greater than 0. Greater than 0, which means negative number you should not be taking in the division. So let's say you have 2, and if you try to divide it by 1, so that is divisible because 1 divides every number. But according to the definition of prime number, 1 if it divides the number, that is fine. Now the next number that divides is 2, so it is basically 2 itself. So apart from these two, there is no any divisor which divides the number, so you should be taking positive, right? If you take -2, that will divide, but you will have -1 as the answer, but it should be not negative, it should be positive. So 2 is a prime number. In the same way, 3 if you try to take, 1 divides and only 3 divides. But if you take 4, so 4 is divided by 1, 4 is divided by 2, 4 is divided by 4 itself. So this is fine according to the definition of prime, because 1 can divide, the number itself can divide, but other numbers cannot divide. So this, whatever is divided, this shouldn't be the case. So 4 is not a prime number. Let's consider the case of 5. 5 divides 1, I mean 1 divides 5, and 5 divides 5. There's no any number which divides. If you try to divide 5 by 2, you will get answer 2.5. But it is not a proper division, right? You are getting some point value. It should be a whole number. So again, 5 is also a prime number. What is 6? 6 is divided by 1, 6 is divided by 2, 6 is divided by 3, 6 is divided by itself. So this is fine according to definition of prime. 1 can divide, 6 can, the same number can divide, but other numbers can't divide. So this is not a prime number. 6 is not a prime number. And is 1 a prime number? Because 1 is divided by 1 and 1 is divided by itself. So according to definition, it looks cool, like it is a prime number, but 1 is not a prime number in the definition website. So now how do we do this? So in the constant, if you see, you have n as 10 power 5, which means this number whatever you have, that is having till 10 power 5, not more than that. So what you will do is you will be taking one divisor which will start to divide from 0, and your divisor will be lesser than n, the number value, and you need to increase this divisor every time, which means you're starting to divide with 2 and checking. Here we will be saying if this n modulo divisor is equals to 0, which means it is perfectly divisible, which means there are numbers which divide n apart from 1 and 2, because 1 we are not considered here, and then n we are not considering because we are taking the number lesser than n. So there are numbers which divide, which means you will take one variable prime. Initially you mark it as 2, you have a prime number, but when you deal with the case wherein you got, like, there are some numbers, I mean there is at least one number which divides the prime number with the number n. So in that case your prime will be false, and you just break out of the loop, and at the end you just return this prime. So this is a pseudo code. So yeah, this will be writing in the code itself, but I just showed on the board. What we need to do is you just take 23, start dividing by 2, you are getting, it's like 11.5, so it is not perfectly divisible, so no. Now you take 3, then you take with 4, then you take with 5, then in the similar manner you take with 6, you take with 7, you take with 8, up till you take with 22. So in this case you will find that there is no perfect divisible, you will be having some point value, which means there is some remainder. So 23 is a prime number. So in this case you will have to display yes. You can do in your pen and paper. So in the first case it is yes. 13 also you will be doing the same thing, you will get yes. Let's start it at 20. So when you have 20, so take 20 and try to divide it by 2. So you will be getting as 10, which means it is perfectly divisible. You have remainder as 0. So which means within this number 1 to and there is at least one number which divides 20, which means 20 is not a prime number. So I think you guys got to know how to solve this. Let's try to code it up. Since n is very small, I'll be dealing with this for loop, but there are other things to do, find the prime number, like sieve of Aristotelian, that I will be dealing in some of the other problems, wherein if you have the number as till 10 power 18 or something like that, because in that case you can't use for loop. If you use for loop, that will give a TL. So let's deal with this only for now. So we will have bool as prime, which will be initially true, or let me call as we'll be checking is prime, and we'll be passing a number n. So if it is a this function will return if it is prime or not. If it is, then we'll display yes, else we'll display no, and at the end we'll have to display handle, which means for every test case we'll have to display yes no in the next line. Now let's try to write this is prime function. So is prime function is going to take n, and in the question they said if your n is 1, it is not a prime number, we just return false. Now you take prime variable, which is initially true. You are saying okay, this n is prime number, and you are taking a divisor from 2, and this divisor is lesser than n. You are doing divisor increasing by 1. Now you are checking if this n modulo divisor, which means n this divisor divides n, which means you don't have any remainder. So in that case, definitely it is not a prime number. You will be breaking out of the loop, because once at least one number you have got which divides n, so in that case it is not a prime number, and then you are going to return this prime. This prime will say if this number is prime or not. Let's try to submit. Right. So we should be getting yes or no, yes. And yeah, we are getting yes already submitted. So it got accepted. So yeah, in this way you could have easily solved the problem. But this is not the optimal way. Optimal way I'll be dealing some other videos, but this is a brute force way. And since the constant were very less, so I've dealt with this problem. This method. So yeah, in this particular we have last problem. So I'll be dealing that in next video.